Hydrolysis of salts. Now this is a topic which is found to be very confusing by students. So let us understand this with the help of a very important question which I have taken here. I am taking the hydrolysis of salts when we have a mixture of a weak acid and a weak base salt. Many questions have come on this from the recent year questions also and the previous year questions also. So please understand this very well. We have been given the concentration of the salt as C molars, any general C molars, and we have been given the Ka of the acetic acid and Ka of NH4OH, which can also be written as NH3. Let us try to solve it. Now why this is mentioned as hydrolysis of salts? First of all, you need to understand that thing. We have been given CH3COONH4, which basically breaks down as CH3COO minus plus NH4 plus. This is the basic breakdown of this salt. This is C molars, this is also C molars, this is also C molars. Okay. Now why hydrolysis of salts? Because we are going to hydrolyze this part, that is we are going to hydrolyze the salts. So that is why the confusion comes into consideration, because of the equilibrium constants. So let me try to make it clear for you. We have the salt as CH3COO minus and we have NH4 plus. Now we do the hydrolysis, which basically amounts to the addition of water in the solution. So when water is added to the solution, we get H plus, which joins with this minus, O minus. We get OH minus, which joins with the NH4 plus. So what we get basically, CH3COOH, H plus goes here, plus NH4OH as the OH minus goes here. Very basic thing. This should be understood by you from the organic chemistry also. At time t is equal to 0, we have been given that this concentration is equal to C and this concentration is also equal to C. At time t is equal to T, this would be equal to some C minus X. This is also some C minus X. Here we would get X and here also we would get the value to be X. Okay, is that clear to you? Now let us move on to the next point, which is what is the value of KH for this? Now why KH and not Ka and Kb? Because we are hydrolyzing the solution. So in order to hydrolyze the solution, we take the constant of hydrolysis, that is the hydrolysis constant. So that is why KH is taken into consideration, because no Ka, no Kb occurs in this particular reaction, only hydrolysis occurs. That is why we take separate constant, that is KH. Now you can see from here what is the meaning of degree of dissociation. If you remember, C gives me some X, you can see C se X aa raha hai. So 1 would give me X by C, that is 1 se kitna aayega, that is known as degree of dissociation. In this case that is known as the degree of hydrolysis, denoted by small h. So X is equal to CH. Okay, so put X is equal to CH in this equation. At time t is equal to T, this equation can be written as C minus X, that is C minus CH. So that is C taken out to be common, into 1 minus H. Here also C into 1 minus H. Here we get CH and here also we get CH. Okay. Now basically the KH for this equation can be written as the concentration of CH3COOH into the concentration of NH4OH whole upon the concentration of CH3COO minus into concentration of NH4 plus. Let us try to do it further. Now before that, let us try to see that what the use of Ka in this equation. So we have been given the Ka of CH3COOH, that is the acetic acid, to be equal to Ka. So CH3COOH would basically dissociate into CH3COO minus plus H plus. Time t is equal to 0. We have been given any concentration, that doesn't matter. Why? Because for this we can write the value of Ka to be equal to CH3COO minus into H plus whole upon CH3COOH. For simplification, let me label this equation to be number 1, Ka to be the equation number 2. Let us use the next mathematical data, that is Kb of NH4OH is equal to Kb. So NH4OH is a base, so that basically would give me NH4 plus and OH minus. So we would get the Kb for this particular equation to be equal to NH4 plus into OH minus whole upon NH4 OH. So this is the third relation which we can get. Now let us see on the next page. Let us try to find the product of Ka into Kb. That is equation number 2 into equation number 3 from here. So that is basically equal to CH3COO minus into H plus, that I would write later, into NH4 plus into H plus into OH minus. Okay, I hope it is clear. Whole upon we get CH3COOH into NH4OH. So this has been mentioned to you. Now kindly see what I am going to do. Ka into Kb, if we assume that this thing which I am labeling here is one particular group, so that basically is equal to what? You can see CH3COOH into NH4OH upon CH3COO minus into NH4 plus. So this thing basically is equal to 1 by KH. So we get from here the value of this thing to be equal to 1 by KH, which has been derived from here. Okay, I hope it is clear. So this thing is 1 by KH. So Ka into Kb is equal to, this thing is 1 by KH into, now H plus into OH minus. What is H plus into OH minus? That is basically equal to Kw. Okay, so I hope that this point is clear what I have derived it for you. It is a very important relation. So from here we get KH, which is the required one, is equal to Kw upon Ka into Kb. Now this thing should be known to you. Why? Because in the question nowhere KH has been mentioned. So if you don't know that how to calculate the value of KH, then you are definitely stuck in the hydrolysis of salts, and that is the people consider it to be very confusing. Okay, now KH is written to be equal to this thing. So KH can also be written as, see what is C double, this CH3COOH is equal to CH. This thing is also equal to CH whole upon C into 1 minus H for this and C into 1 minus H for this. So that becomes C square into 1 minus H whole square. So this gets cancelled out, the C square, and we get the value of KH to be equal to H square whole upon 1 minus H whole square. This is also another important relation. Let me write it for you. So we have also got the value of KH to be equal to H square upon 1 minus H whole square. So these are the two relations which I have derived for you. Since this is a revision video, so please focus on it very well. The important concepts are discussed here. Since the question is asked about the pH of the solution, so our major focus should be on the H plus concentration, which can be found out from Ka, the equation number 2. So from here H plus basically is equal to CH3COOH into Ka whole upon CH3COO minus. Okay, now what is CH3COOH? That concentration is equal to CH, which is clear from here. So CH into Ka whole upon CH3COO minus, which is equal to C into 1 minus H. Okay, I hope it is clear to you. C and C gets cancelled out. So we get the result to be equal to Ka into H by 1 minus H. Now what is the value of H by 1 minus H? Taking square root, we get the value of H plus to be equal to Ka. H into 1 minus H becomes, H upon 1 minus H becomes root of Kh, which can also be written as Ka into root of Kw upon Ka into Kb, and H plus can also be written as, taking the root from here also, we get Kw root into Ka whole upon Kb. So we have got the net H plus concentration in the solution. The important point to realize from here is that H plus concentration is independent of the C. Whatever C was given to you in the question initially, 0.1, 0.01, whatever has been mentioned to you, the final H plus is independent of that. So it means that the final pH would be independent of any initial concentration which was given to you for the salt. Okay, so please remember this point also. I proved it for you right now. Now we need to find out the pH of the solution. So pH is equal to minus log of H plus. So that is equal to minus 1 by 2 log of Ka plus log of Kw minus log of Kb. Now from here we can write the pH to be equal to C. Now see very carefully what is going to happen. So minus 1 by 2 log of Kw is taken outside, minus 1 by 2 log of Ka plus 1 by 2 log of Kb comes into consideration. So pH is equal to minus 1 by 2 log of Kw, log of 10 raised to power minus 14 is equal to minus 14, minus, let me take 1 by 2 to be common from these two, we get minus log Ka, so that is equal to pKa, plus log Kb, that is equal to minus pKb. So here we get a value of 7 and the pH comes out to be equal to 7 plus 1 by 2 into pKa minus pKb. Okay, with practice it seems very easy. Okay, I had done a lot of practice during my preparation, so that is why I remember till now also. So this is how you derived the things. Many important concepts actually come from the derivation, like H plus is basically independent of the concentration. These two important relations have been derived for you, and finally the pH comes out to be this one. Now my question to you is that if pKa is greater than pKb, what you get the answer as? You can say pKa is greater than pKb, then we get 7 plus 1 by 2 into something positive. So pH is greater than 7, which implies that the solution is basic in nature. Similarly, you can derive the conditions for pKa is equal to pKb and pKa is less than pKb, then the solution would come out to be acidic. Okay, so I hope that this point is clear to you.